Welcome back, guys. As promised, here are the notes for Symmetry that I got you started with on that video and TikTok. But in any event, this is just another section in our transformation unit. It is not a transformation itself, however. It's kind of like a characteristic of transformations. But the objective for the day is going to be able to identify types of symmetry. And it starts off with a warm-up on the notes here. Again, these are in your folder then if you want the blank ones, or you can use the filled in ones, whatever you would like. But as a warm-up about rotations, again, that was the last type of transformation we looked at. Basically, we had 3 different rotations. Again, you can rotate them in any way, but these are the common ones of 90, 180, and 270. So again, you could either memorize what happens to the pre-image and image when you go through these. So for instance, when you're rotating 90 degrees, again, you're going to change the Y and well, you flip the X and the Y becomes negative. So if I want to do this one 90 degrees, again, my R prime, I just flip-flop the X and the Y and change the sign on the Y. So the Y would become -3, and I'd move it to where the X is. And then this stays -4. So it becomes -3, -4. So -3, -4. The image point would be 1, 2, 3, 4. So that's where R prime, if I did the 90 degrees rotation. Remember, I also taught you could just use a piece of paper that you're doing your homework on. So again, if I wanted to graph 4, 3 on here, that's going to be at what? -1, 2, 3, 4, 1, 2, 3. So that's my pre-image point. That's green, you can't see. Let's use black so you can see. So pre-image point at -4, 3. So again, 90 degrees would indicate, since there's no direction mentioned, you go counterclockwise, which would be this way. And you can see you end up down here at the 3rd quadrant, and I end up at -1, 2, 3, -1, 2, 3, 4, which is the exact same point that I got here. So you could either turn the paper or use the rule. So again, if I want to rotate this 180 degrees. What's up, Joey? You want to say hi? There's
Yellow.
the star of all the, what did you say? YOLO?
Bellow.
Oh, bellow. Oh, okay. So again, you could either use the rule or turn the paper. So if I'm going to go 180 degrees now, I'll use a different color for that one. So let's do 180 R prime then. And when you do 180 degrees, that's where you just change the sign of the X and the Y. So if the pre-image is at -4, my R prime will be at +4. And if my pre-image is at +3, this would be at -3. So then I graph that on here, down 1, 2, 3. So that'd be my R prime there. So again, do that, or again, I could just turn the paper. There's my pre-image point still from before, and now I'm going to go 180 degrees. So there's 90, 180, and then you can see that it ends up in the 4th quadrant there at 4, -3. 270. So for 270, again, I'll use a different color on that one. So now if I do 270, the rule is what? I flip and change the sign. So R prime on 270 is I flip and change sign. So this would become 4, and then the -3 would become +3. So it'll be up in the 1st quadrant there. So 4, 1, 2, 3. So that would be my R prime if I rotated it 270 degrees. Again, if I did it on my board, there's my pre-image point. Go 90, 180, 270. You can see how you end up in the 1st quadrant there at 4, 3. So that was rotations, what we've been looking at the last couple of days. So again, reflections, with common reflections we looked at, again, where you flip it over the x-axis. So remember, if I'm at x, y as my pre-image, this is a good review of all of them. If I flip it over the x-axis, remember that the y value only changes on this one. So if the xy is my pre-image, my image would be x -y. And then if I flip it over the y-axis, x becomes negative. So that would be -x +y. Really hard to write on this. If I flip it over y is equal to x, remember you flip the y and the x, so it becomes x is y now, and y is x now. And then if I flip it over, y is equal to negative x, same thing except you make them negative. So this would be negative y and negative x. So those were just patterns of those reflections. Then we looked at translations. Again, we could slide. These are just sliding. Here you're just using words. Coordinates, again, use these parentheses. And then the vectors use these. And you just kind of steal the numbers from the coordinate ones. And then last we did those rotations. And that's what we just did on the warm-up. So again, on the rotations, if I have x, y as my pre-image, and common patterns where you could turn the paper. Remember the 90-degree one, you end up with negative y and positive x as your image point. Then when you do it 180 degrees, you change them both negative. So the image point would be negative x, negative y, negative x, negative y. And then lastly, 270 degrees, that's where you're going to flip and then change the sign on the x value. So you end up with y, negative x. And so those are some common rotations that we looked at over the last couple of days. So today what we're going to do is we're going to continue on and look at the concept of symmetry itself. A few definitions. Symmetry itself, I'll type this in so you can read it. We'll say a figure has symmetry if and only if there is an isometry that maps onto itself. Again, that mapping onto itself, I never really understood what that meant as a kid. But again, what that means is basically I showed you how I folded that hexagon. That's when the shape kind of collapses right on top of itself. So do I have shapes up here I can use? I do have shapes up here. So an example of mapping onto itself. Oh, here's a good example right here. So if I take this heart, this has line symmetry because what I can do is I can draw a line from here to here. And again, this part over here, I could fold it over and it would map onto itself, is what that means. So that's what that whole thing means. This line that I drew right here, we'll be spending a lot of time on that. That is the line of symmetry. So that line that I did draw, we'll call that line of symmetry. Just so you know what I'm talking about. I'm going to abbreviate that because it's painfully slow to write that in there. All right, so there's a couple different types of symmetry. Reflectional symmetry, that's kind of what I just kind of showed you on the heart right here. If I had to define what reflectional symmetry was, it is when 1/2 of figure is mirror image of the other. And again, a heart's not the only one that's going to happen in. I can draw, I can draw like an isosceles triangle. That would have reflectional symmetry. An equilateral triangle. That would have reflectional symmetry. Any regular polygon actually is going to have reflectional symmetry. I'll do one more with that like I have. Octagon. No, hexagon. Do I see a hexagon? Here's a hexagon. So these all have reflectional symmetry. So if it asks for lines of symmetry, those are lines that are going to have a mirror image on either side of it. So again, it would be through the vertex angle for, that's a terrible one. It would be through the vertex angle on an isosceles triangle. So again, that would be my line of symmetry. Same thing here. This has multiple lines of symmetry though, one for basically each angle. So these are all lines of symmetry because it kind of breaks it in half, just like that. Over here, this has a bunch of lines of symmetry. Here's 1, here's 2, 3, 4, 5. So it's basically one for every side. Oop. The last one in there is this one. Something like that. Again, hexagon. It's got different ones. So this would be a line of symmetry. So with this, there's a third one. But there's also a line of symmetry for the sides being bisected, basically. So this would be a line of symmetry. So again, there's 3 for the angles, 3 for the sides, for a total of 6 different lines of symmetry on that regular hexagon. Those are all lines of symmetry. Then there's another type of symmetry. That is rotational symmetry. It is when it can be mapped onto itself by rotating the image. So again, I could use regular polygons to illustrate that as well. So again, I'll use the hexagon again. So the center of rotation again is going to be the center of the hexagon itself. So again, if I spin this, again, if I illustrate this side right here, kind of keep your eye on that side. If I spin it clockwise this way, I'm going to spin it until it maps onto itself. When it maps onto itself, that side's going to be over here. Now, how far I turned is basically going to be one of these central angles, which we've looked at before. So that would be the degree measure of the rotational symmetry. To figure out what that is, basically you got to take 360, which is the whole thing, and then divide it by the number of those equal parts. So the number of those sectors there that I have drawn in green, well, there's one for each side, so that's going to be divided by 6. So 360 divided by 6 is equal to 60 degrees. So a hexagon said to have 60 degrees of rotational symmetry. Take the triangle, we'll use the triangle again. If I can clone this. So if I just look at the equilateral triangle, so it's also going to have rotational symmetry. Now when I kind of pick a side here, I'll pick this side, and I'm going to rotate that around this center, and again I'm going to spin it until it falls on top of itself, which was where the red side would fall on this over here if I spin it clockwise. Now how many degrees I went there, again, is equal to one of these central angles. And again, I can figure out how big one of those central angles is by doing 360 divided by the number of those equal parts, which is 3. So this is said to have 120 degrees of rotational symmetry. So that's what line symmetry is and rotational symmetry. And then it has some example questions. A figure has blank if there's an isometry that maps onto itself. Again, that's the definition of symmetry. If the symmetry is reflectional on a plane figure, then it's said to have reflectional symmetry. Sometimes it's called reflectional. Actually, let me type that in. Reflectional or line symmetry. So that's what goes in those two. So it looks like I'm going to run out of time, so I'll probably have to come on with another second video. This only goes to 15 seconds. But that last one is if an isometry is a reflection of a plane figure, that figure says to have reflectional symmetry or line symmetry. So look forward to talking about all of this in part 2, where I'll continue on with the notes. I'll talk to you then.